Hello everybody, and thank you for joining Qumulo today for our webinar. Today's topic is expanding your most demanding workloads into the cloud. My name is Brian, and I'm here on the marketing team. I'll be joined by Joel, who's our principal product manager and just a huge resource of knowledge around cloud storage and cloud computing in general. So just to set the tone for today's presentation, just keep in mind that this session will be recorded. And they'll also be available for on-demand viewing. If there's any parts you want to go back and watch or share the presentation, this will be available after the webinar. We do want to make the session interactive, so please feel free to ask any questions at any point during the presentation. On the right side of the screen, there's a little box for you to type in your questions. We've also provided a couple of resources that you can download that sort of augment the experience and the material of the presentation. And then one last thing to note, we did schedule this for an hour, but we think this is going to be closer to 30 minutes all said and done. We just wanted to make this a very direct and targeted material for the presentation. So with that, let's get things started and hand things off to Joel Gruen, our Principal Product Manager.
Okay, thanks Brian, and hello everybody. Today what I want to cover with you is really just talk a little bit about what's happening with file workloads inside of the public cloud. Talk a little bit about one in particular that will go into a fair amount of detail with some use cases, and talk a little bit about the problems that Qumulo is helping our customers solve in that world. And then we'll wrap up with just a short little bit about Qumulo, and then go straight from there into questions. So, as Brian said, if you have questions, please enter them, and we will aggregate them and go through all of the questions that we have time for at the end. So what we're going to talk about today is really about file-based data and how it continues to drive innovation in the enterprise. And we'll, in a little bit, talk about some specific verticals where we're seeing that happen. But really, when you talk about some of the emerging industries, artificial intelligence, machine learning, some of those things, IoT, there is an incredible amount of file-based data being generated, and more importantly, being analyzed as part of these new workflows that are driving innovative companies forward into the next generation of our economy. So let's talk about how the cloud plays into that. So what we've seen and what we are helping our customers do is really move their large-scale file data sets to the cloud. And what we've seen to date is obviously the cloud born out of object storage, in large part, not entirely, but in large part because there just wasn't the ability to scale file to the level that was necessary to manage some of these really, really large multi-petabyte data sets that people want to manage in different places, both on-premise and in the cloud. So if you look at the three options here, right now you do have some cloud-only file providers that just don't allow you to have a hybrid type of workflow, as many customers are still storing lots of data on-premise but need to move all or part of that to the cloud at various times. And then you've got the legacy vendors that are trying to port what they built 15 or 20 years ago into the cloud with an experience that leaves lots of customers wanting a more modern experience for what they're trying to accomplish in the cloud. And then there are obviously some people that are trying to help you navigate a file to object conversion, which comes with its own challenges of both scale and performance. So we're going to talk now about the four kind of very high-level use cases that we are helping customers in the cloud today, and then we'll dive into one of these, which is kind of the whole focus of today's webinar. So there are these 4 workloads that we can talk about. One is really taking advantage of the elasticity of compute in the cloud and being able to move data sets to and from the cloud and use the resources that are available in the cloud to spin up and spin down really large compute resources for lots of different workloads. And this is where we're going to spend the bulk of our time on the webinar today. We are getting asked from customers who have either traditionally been on-premise or who are very young companies that are just starting up in brand new, exciting industries that have decided that they're not going to run data centers, and they're going to figure out a way to use the cloud to be their primary storage. And obviously, an important piece of that is their file data, and so they need a scalable, elastic way to manage file in the cloud. And as companies have increased needs to collaborate either within their company to branch offices and other offices around the world, or as more companies share data in a collaborative manner, whether that's through some large research project that might be, grant funded and they need to share the data across many organizations, or other similar types of scenarios where you need the ability to share data and have caches of that data in different locations, whether that be a full copy of the data or maybe a sparse copy where you can get access to some of those assets but may need to download others as needed. And then finally, the one where on-premise to cloud kind of got started, maybe the least interesting of them is just a purely economic choice for those companies that have decided that tape or some other kind of cold storage medium doesn't need to happen on-premise anymore, and they can just pass that resource off to a cloud provider, and they don't need to worry about it again. Typically, those are associated with data sets where access time is not an issue. But for us today, we're going to talk about the first of those 4, and that's really about the power of the public cloud in particular to have a bunch of access to compute. And so let's just talk a little bit about what we mean to get on the same page about cloud bursting. So what we're talking about is typically an organization that has some compute resources, typically in their own data center. It could be in a colo or something, but has needs to expand that compute either when they're up against a deadline or if there's a specific project that they have in mind where they just need short-term access to a lot more compute resources than they either have room for in their data center or that they don't want to spend capital money for and would rather spend short-term OpEx money to be able to do a bunch of compute in the cloud. What that means is you have to be able to move data back and forth in an intelligent manner so that the data is where you need it, when you need it, when it's time to spin up all of these compute resources. And we'll talk a little bit of that in one of our examples as we get later into the presentation. And then it's important to note that in many cases, when you move the data up to the cloud, you might be moving it up there purely on a temporary basis, and you might actually just be putting a copy of one piece of your data set up there and computing against it, and then you no longer need that, and you might just might delete that copy and just bring back down the results of your computational work and bring that back down to your on-premise cluster. So those 4 things really make up what we define as cloud bursting. So if we talk a little bit about the industries where we see a lot of that happening, and Qumulo has examples in all of these, and they're all associated with the need for high compute environments. And so you can see the list here, and we're going to talk about two of them in some detail today, but all of them have their own computational needs. A really, obviously, the IoT of things drives a lot of this, and we're seeing a lot of traction. One of the areas that we're not going to talk about today, but certainly could be its own webinar, is the growth of autonomous vehicles, and there's some really exciting work going on where a car could go out for a drive, and the sensors on that car can generate up to 20 or even 30 terabytes of data in a given drive, and all of that gets brought back in and put into file storage. And then every time you have new data, or every time you make a change to some of the autonomous driving algorithms, you need to rerun that entire data set. And so the computational needs of a process like that becomes very, very large. And so we're seeing more and more companies take advantage of the elasticity in the cloud to help them smooth out their computational cost, if you will, across what they own in their data center and using one of the public clouds to help them do that. Okay, so let's go into a couple of real-world examples. The first one is in life sciences, and this one is from one of Qumulo's customers. It's associated with the University of Washington in Seattle, Washington, and they are using AWS as their cloud provider, and they have built a version of a Qumulo file system inside of AWS to help them move data up into the cloud for some of their heavy computational workloads. And as we talked about just a little bit earlier, they then take the artifacts of that computational work and bring it back down, and then they don't need to worry so much about the data that they moved up, because that's the raw data which they keep a copy of on premise, and the resulting artifact of all of that computation then they can bring back down and take on to the next step of their workflow. The second one that we want to dig in on a little bit is a customer of ours, FuseFX, and they have a very similar issue that they use the cloud to help them with, and there's actually a pretty good use case on the Qumulo website that will give you some more detail around this, but we'll dig in a little bit about exactly what they're doing. So this is in the area of media and entertainment, but it is just, it's really an example of many of how compute resources and storage are being used together in the cloud. They also use AWS, and they have a cluster that they move. They have a workload that I'll show you here on the next slide. But the basic issue that they have is they develop as a visual effects studio. They have agreements with different studios around TV shows, and you can see a couple of them listed here on the slide. And they have deadlines. They have specific scenes that they need to deliver on a very strict timeline so that they can be part of the production of a long-running series where every week they have to produce. And in certain cases, they fall behind, or there is a glitch in their rendering workload, and they know that they have AWS as their backup. And so one particular case that you'll see in the use case, they set up their rendering workload at the end of the day after all of their artists had done all of their work, and for whatever reason that rendering job just did not run overnight, and so they came in the next morning with the realization that none of their frames had been rendered overnight, which fortunately for them, they already had this workflow built inside of AWS, and this is actually a slide from reInvent, the AWS reInvent show, where they talked about this. And so this workflow allowed them to very quickly spin up tens of thousands of cores into a giant render farm, and basically in a few hours they were able to catch up with all of the rendering that didn't happen overnight. Now, obviously there was a cost associated with that, but the cost to do that in AWS was peanuts compared to having to make a call to one of their studios and tell them that their frames were not going to be ready at deadline. So let's just quickly walk through this particular slide. So the big box on the left with VPC, that is what they have running inside of AWS, and on the right is their on-premise infrastructure. So if we start there with their on-premise infrastructure, they have multiple clusters on-premise where they store both their digital assets for all of the VFX work that their artists do, as well as specific episodes and frames within those episodes for many of the different shows that you saw on the previous slide. They have a Windows render farm that they run on-premise in their own data center that is used for the bulk of their work. And you can see the blue box called Nucleus is actually a workflow management system that they customize themselves to allow them to move data back and forth and make sure that the assets and the frames that need to be worked on are in the right place when they need them. So in this particular case, they were able to take data that was on their on-prem cluster and use their Nucleus asset manager to make sure that the Qumulo storage that you see on the left there that's running inside of AWS was ready and populated with the files that they needed, so that when they needed to spin up a lot of compute nodes, and you can see those, they happen to use spot instances within AWS, but any type of compute would work. That's their particular workflow. And so they were able to then create a very, very large render farm in a very short amount of time, have the data available to them, and then take those finished frames and move them back down to their on-premise storage. And so that's an example of them being able to use the elasticity of the cloud to do that. So if we now just dig in a little bit and kind of zoom in on that cluster that was running inside of AWS for them, it's built using M4 class EC2 instances, which are kind of a general purpose compute instance inside of EC2, and then we back it with EBS, which we can put both high performance SSD-like storage underneath that instance, as well as more traditional general purpose storage, so that for reads and writes you get that performance that you need from an SSD layer, and back it with less expensive general purpose storage. So they have a 4-node cluster that they run inside of AWS. Each of those nodes is 5 terabytes, so they have a total of 20 terabytes of raw storage inside. And then you can see from that particular configuration, they can get the performance that you see here. So what's important for them is if you are spinning up that huge amount of compute, and we have customers that are using GPUs to do really, really super high performance computing. If your storage can't feed that compute in a quick manner, then you're not being able to take full advantage of the compute performance that you're paying for inside of your cloud provider. So it's important that you be able to spin up high performance nodes of storage and have it sit very close to your compute, and that's the power of what we've been able to do for companies like IHME and FuseFX and others. So in this case, this is a pretty standard performance model that you would see on a per node basis. Obviously, Qumulo being a scale-out architecture, every time you were to add a fifth or a sixth or however many nodes you needed, you would be able to add that much more performance for your cluster. So you can get very high performant access. In fact, these are pretty sustained numbers. FuseFX at times we're getting throughput of about 20% higher than this at peak levels, and they hit IOPS on their 4-node cluster of almost 50,000 at one point off of 4 nodes. So very high performance, likely the highest performance file system that you can run inside of the public cloud today, and that allows you to take advantage of that elasticity in your computing. So a more general look at that, now if we go back to the FuseFX example, they had Nucleus, which was kind of managing the flow of data between their on-premise cluster and their Qumulo cluster inside of AWS. Many of our customers are using Qumulo's continuous replication to do the same thing. Because you've got directory by directory replication, you can pick a specific directory that has the file data that you need and set that up to on some kind of schedule or continuously change data up to AWS and have it available when you need to have your compute available to you. So oftentimes they'll have a specific directory that they can just drag and drop the data that needs to go up to AWS, and then they have continuous replication turned on, and then it automatically just moves the data up. And in some cases they leave the data there for long-term persistent storage. In the case of machine learning, you're going to have a data set that every time you make a tweak to your algorithm or every time the data changes a little bit, you're going to rerun that as part of your machine learning exercise. So you need to have the ability to both persist the storage there if needed, as well as have it ephemeral just for cost purposes if you need it just for a very short amount of time. And then you could always build another cluster, move more data up, and we have customers that take advantage of both of those models. Okay, so now a little bit just about Qumulo and what we do. So we are a software company that has built a universal scale file system, and that file system allows us to run both on-premise and in the cloud, as we've just talked about, and we have hundreds of customers that are using us in mission-critical types of environments. And one of the really important things, especially when we're talking about compute-intensive workloads, is being able to have your file data where you need it, when you need it, and that's a very important aspect of what Qumulo offers to its customers. And we are built to scale. Clusters that grow into the billions of files help our customers manage really, really incredibly large data sets and take pieces of that data and move it around for them as they need it. And And lastly, we have a very modern approach to customer success and helping our customers be successful in a proactive manner that makes sure that we can help them solve the problems that they're trying to solve with their storage. So one final slide just to look at how the Qumulo File Fabric, or QF2, works. It's really a network of data storage, file data, again, running on a variety of environments, whether that be on-premise, running on a variety of different hardware types, or in the public cloud, and then again allowing you to manage that data so that it is where you need it when you need it. And so with that, I will turn it back over to Brian, and I guess we can jump into questions.
Great. Well, thank you, Joel, for that great presentation. We do have a few questions that I wanted to get to before the end of our presentation here. So to get things started, Joel, I have a question about how scale-out works in AWS. Can you take a few minutes to explain that?
Sure. So for those of you on the call, you're probably at least somewhat familiar with scale-out on-premise, and it works in a very similar manner. You build what would equate to a node with EC2 as your compute and networking, and EBS volumes as your underlying data storage, and those pair together to become a node, and you cluster those nodes together in the same way that you would on premise, and you can have a one node instance in AWS and grow that to as large as you need to. We've had let's see, I think it was a 1.8 petabyte system we spun up a couple of weeks ago just as we were doing some testing, and so these can grow very, very, very large. And the power of the cloud is that you can take very small nodes and scale out to a very large number of them and get crazy good performance, or you can build nodes that are very, very big and not need as many of them to run, and either of those are possible.
Great. So I have another question. So what are the times that someone might not need a lot of performance? What would they do in that instance?
Yeah, so the power of the cloud really is about capacity and performance and cost, and those three axes. Cost typically being a function of the first two. In a traditional, on-premise, hardware-based scale-out model, you add more nodes, and in a linear fashion, you grow additional performance and capacity every time you add a node. That is not the case in the cloud. You should be able to scale performance and capacity independently, which is one of the very powerful things about our solution in the cloud, and that is if you have a workload that is very, very performance intensive, we can use EC2 instances and EBS volumes underneath to create a very, very high performance cluster for you, and then as that performance wanes because the work is done and now you just need some persistent storage in the cloud, underneath we can just swap out that high performance infrastructure for lower performance, lower cost infrastructure, and you can have that ability, and that's the power of running inside of AWS and its elasticity.
Great. So let's have one more quick final question. It's around how can I test QF2 in AWS?
A couple of different ways. One is that the easiest way by far is on our website. There is a page you can go to, and you can just download a free instance of our QF2 software that will run in AWS. All you have to do, it's a private AMI, and so all you have to do is associate your AWS account number with it, and we'll just let you use that for as long as you want. It's a small 5 terabyte single node instance that you can run, and it's the exact same software that you would run in a clustered mode or on-premise for that matter. So you can get a feel for Qumulo. You're probably not going to be able to get an actual real performance benchmark, but we would be happy to work with you if that was something where you wanted to do some performance testing.
Okay, great. Well, thank you, Joel. And thanks everyone for attending today. And another quick note, if you do want to try QF2 on AWS, we have a link right here in the presentation, as well as some other assets that you can download if you'd like some more information. And again, thanks for joining us today, and hope to see you next time. Thank you.